Hello, and welcome to our April edition of the Forest Restoration Talks. For those who haven't joined the talks yet, we're a webinar series, a monthly webinar series jointly organized by the Superb Project and the IUFRO Task Force, Transforming Forest Landscapes for Future Climates and Human Well-Being. And today we will discuss tree planting and water cycling. And as you can imagine from the question, we will figure out if this is always a win-win situation or not, and if we can make it and how we can make it a win-win situation. And today we have two speakers who will be introduced by Andreas Beuter, who is the moderator together with me today later, but I still want to kind of introduce them briefly. Mingfang Zhang and Yanhui Wang will have two different presentations today. And now I would like to continue with the housekeeping. Next slide, please. Yes. As you've already been informed when joining the webinar, this webinar is being recorded, and you can watch this webinar or share it with your peers later on. Usually we publish it a couple of days later on the EFI YouTube account and on the IUFRO website. If you have questions to the panelists, which are very welcome because we want to make this as interactive as possible, then please use the dedicated Q&A box and be ready to be promoted to a speaker so that you can ask the question live. In case you don't want to be promoted as speaker, you can also just refuse the promotion, but usually it's much nicer if we can also see you and that you can have a real interaction with the participants from all over the world. And if you want to tweet about the webinar, please tag us using IUFRO or the Superb Project. And now I would like to hand over to Andreas Beuter, who is the main moderator today, and I will support him. Andreas, you have the floor.
Yeah, thank you, Gesche, for the nice introduction. Yes, tree planting and water cycling. I think trees and forests on one side and also water cycling on the other side are, within the focus all of the discussion of climate change, climate protection, because perhaps we all know about water shortage in some parts of the world, about global warming, but on the other hand, also, trees and forests as a solution, as organisms who are able to absorb carbon dioxide and so on. So the idea today is also to discuss about this interaction between trees and forests, and also on the other hand on water and water cycling. And I'm really glad that we have really two true experts in this field, especially on the interactions between trees and forests and water cycling. And I would like to introduce our first speaker, which is Mingfang Zhang. She graduated from University of British Columbia, so UBC, and received a PhD degree in environmental science. And she's now a full professor and head of the Department of Environmental Science and Engineering at the University of Electronic Science and Technology of China. So her expert field is ecohydrology, and with a special focus on the interactions among forest, climate, and water across different scales, and also all ecosystem services related with water. And so I think she is really within the focus and really an expert about talking us about these interactions and all kinds of issues and options with forest restoration and water. And of course, she is also experienced in eco-hydrological modeling and also works with remote sensing techniques in the field of hydrology. So it's really a pleasure to have you here, Mingfang, and the floor is yours. Please start with your presentation.
Okay, thank you, Alice. I need to share my. Okay, so it works. You can see my screen.
Yes, we can see it, but it's not in the presentation mode now.
Now it is.
Perfect. Now it is.
It's not in promote.
It's good now.
Oh, it's good now. Okay. There may be some delay. Okay. So thank you, Anders, and thank you, Just. Yeah, do I pronounce the right name? Okay. So it's my great honor to be invited to join the monthly forest restoration talk. And I found that it's very interesting topics regarding the forest water nexus in the forest restorations. So today my topic is I will give a general background of forests and water relationship and mention the challenges that we confronted with in forest restoration that related to forest and water interactions. So, as we all know, forest plays a very vital role in water cycles. For forested catchment, and they have very special hydrological process, such as the canopy interception, transpiration, evaporation, and infiltration, and the surface runoff generation. And this hydrologic process will generate various important hydrological services, or also you can call it water-related ecosystem services, and that include flow regulation, water purification, water supply, soil erosion control, aquatic habitat sustaining, and the climate regulation. And currently, our global forests are changing dramatically, and we are expected to have more frequent and catastrophic forest disturbances such as wildfires, insect outbreaks, and as well as loggings and the deforestation such as conversion of forest land to agricultural land. And these are caused by human activities and climate change. And also on the other hand, we have large-scale forestation that are performed in some regions on Earth for ecological benefits. Example could be the China leads the greening in the world through land use management. And we have very ambitious plans to grow more trees. And we plans to increase our forest coverage to 60% in 2050s, to enlarge our forest carbon stock to reach the carbon neutrality in 2060. So on the Earth, generally, the global forest is still on decrease, according to the FAO's recent assessment. But there are regional differences. And in Asia and Europe, we have forest gains. But in South Africa and South America and Africa, we have forest loss. So this forest change, they will inevitably impact water cycle. As we said, forest plays an important role in water cycle. And so this forest change impact our water supply from the local to regional scales, and through altering the evapotranspiration, altering the stream flow generation, and also by altering the precipitation recycling. So as a matter of fact, related to the forest and the water relationship, it's a very old topic. And we have studied the forest nexus for over 100 years. And there is a long-term debate on forest change impact on water jet or stream flow. And according to a global review I have performed in 2017, and we found that deforestation generally increase annual stream flow in both large and small watershed. And more than 80% of the deforested watersheds have annual stream increase, at varying from 0.4 to 591.1%. But we need to notice that the hydrological response are highly variable among watersheds. And for the forestation, including afforestation and reforestation, and it can either increase or decrease stream flow, especially in the small watersheds. And according to our analysis, 60% of the forestation watersheds have annual stream flow reduced by 0.7 to 65.1%. And whereas 30% of the watersheds have annual stream flow increased by 7 to 167.7%. And also, we also found that this response are very highly variable. And so it seems that there are more complex variations in the annual stream flow response to forestation due to the differences in site conditions, the tree species selected, forest ages, forest structures, and also our managed measures. And they generally found that plantation with a single fast-growing exotic species can always have greater reduction in annual stream flow than with native species. And for example, there's large plantation of non-native species such as eucalypts in Brazil, in China, and in Australia, or the young plantations, they always have more pronounced negative effect on stream flow. And also, we also found that the stream flow reduction after forestation are often common, especially in the semi-arid and arid regions than in the humid subtropic and the tropic regions. And a good example could be the Loess Plateau in China. We have large-scale vegetations, and we found that the revegetation is approaching the sustainable water resource limit. And I think Yanhui will give more insight on this special place, the studies in this place. And we also found that the reduction of stream flow after forestation, especially for the low flows due to forestations, can often last many decades. That means the hydrologic recovery after forestations are very hard, are very difficult. It may take longer time to see. So that's the general background about the forestation that may have on our hydrological process, especially the stream flow. So what are the implications for our future forest restorations? And for forest restorations, and one of the major goals is to restore the hydrological functions and the services provided by forest. So what are the challenges we are facing? I think the first challenge is that flow recovery, especially the low flow recovery, that after forestation or forest restorations is very difficult to be achieved due to the great difficulty to restore the damaged soils. As we all know that the deforestation that can often lead to severe soil erosions or soil loss or soil damages, and it's difficult to restore the soils through forest restorations. And the second challenge we need to face is how to manage the water consumption and carbon sequestration in forest restorations. And we may notice that there's a debate about the carbon and water. That I think that's why we have the topic for this monthly talks. Some scientists, they found that we have more carbon with less water. So there is a trade-off relationship between the forest carbon and water consumption. But also there are also studies in some regions that found that there's synergies between the water carbon and between the forest carbon and the water consumption. That means if we have less water, we have less carbons. So there are trade-offs and a synergy between forest and carbon and water, but there are driving factors and the mechanisms behind the forest carbon and the water relationships across the scales, from the slope scales, the stand scales, to catchment scales, to watershed scales, or even regional scales remain poorly understood. So that's the second challenge. And the third challenge is, how do we promote hydrologic functions and services through forest restoration under climate change? We are under climate change, and the climate change can impact forest and water indirectly and directly. For example, climate change can alter the growth structure and the forest cover and the productivity, carbon sequestration, including the distribution of forest. And it can also directly impact the water quantity, water quantity, and water supply and water demand as well. And on the other hand, it can also alter forest, and so it can indirectly impact the water, impact the stream flow. So climate change impact both water and forest directly and indirectly. And there are very complex interactions and feedbacks among forest, water, and the climate. So in our future, when we design our forest restoration measures, we need to consider the climate impact on forest and water, as well as their interactions. So we need to design the adaptive forest restoration practices for managing the forest-water nexus to mitigate the negative impact on water under climate change. So in conclusion, I think that there's very important role forest plays in water cycle. And so promoting the hydrological functions and the services is an important goal for our forest restorations. So for our future forest restoration measures, we need to consider the trade-off and the synergy between the water consumption and the carbon sequestrations. And also, we need to consider the climate change impact on forest-water nexus to develop our future adaptive forest restoration measures under climate change. So that's all my talk for today. So there will be a question.
Yes, thank you very much, Mingfang. I think it was really an excellent introduction into this topic. Yes, and we discussed that I will allow perhaps only question for clarification. Are there any needs for clarification on the talk? Because otherwise we will then continue, because as you already mentioned, there's a strong link between both presentation of you and Yanhui. So, and are there any needs for clarification directly?
No, I don't have any clarification now. Maybe we can ask Yanhui to make the presentation.
There are no questions in the chat either, so I think we can continue.
Yeah.
Okay. And have the questions after both presentations.
Okay, yes. Thank you.
And then thank you again very much, Mingfang. And one thing I forgot to mention, because but you showed it up also on your slide, that you both are active also in our in the IUFRO task force on on forest and water interactions and changing environment. And I guess some of also the presentation you and also then Yanhui will present are also part of the work, I think, in this very successful task force. And we're also cooperating in our task force. So Thanks again. And it's now really my pleasure also to introduce Yanhui Wang. Yanhui Wang graduated from Beijing Forestry in the 1980s. And then, as it's really a pleasure because it's also my alma mater, he completed his PhD thesis in Germany at the University of Göttingen. And now he is research professor at the Chinese Academy of Forestry. And he has really a long career, and he was engaged in many studies on forest ecohydrology, especially in dryland areas and dryland regions in northwest China. We had already, Mingfang already talked about the Loess Plateau. And I think he's one of the leading experts in all the question what are the limits and the options of forestation and forestry within this dryland regions. Yes, and he has also different roles in IUFRO in different divisions. He is also in the editorial board, and he is deputy editor-in-chief for different journals like the Journal of Forest Research and in other areas. So it's really a pleasure, Yanhui, to have you here, and we are really looking forward to hear more about the options limitations of forests and water. Thank you.
Dear ladies and gentlemen, I'm Yanhui Wang from Chinese Academy of Forestry. I'm very happy to be here to have the chance to share our research. The title I present today is Water Adaptive Multifunctional Forest Management with dryland cases in Northwest China. Here is the outline, background, techniques of multifunctional forest management, and summary. First, talk about the background. We have vast dryland areas with serious soil erosion and water shortage. Forests can supply multiple services, including soil protection and water regulation. Therefore, massive afforestation was encouraged worldwide, typically in the Loess Plateau areas of China. We have 50 years of afforestation. It was a success to increase vegetation cover and reduce the soil erosion, but significant water yield reduction was observed. Also, low growth, low stability of the overdense stands. This means that in the management, we should pay attention to the water limitation and the competition service relation. This means that we are facing a big challenge: how to manage the forest in a water adaptive way. It should be based on the water carrying capacity at multiple scales to ensure stand stability, water supply security, and the full use of all ecosystem services. But you can see for this table, we have different approach for forest management, but no one of them can meet all the requirements above. They usually use the forest cover as a proxy of the ecosystem service. This means that we need to create a new approach for the forest management. It should be multifunctional forest management. This is the future of our forestry. Then we talk about the techniques of multifunctional forest management. We have a long-term study in the dryland regions to understand the forest water service interrelations and to explore the techniques. We proved that the multifunctional forest management is feasible by a few cases, addressing the key issues of why and how much to afforest and where to afforest, and which water species and the stand structure to manage the forest. You can see in this table, we divide the decision in 4 steps. First, forest cover, then spatial distribution, then vegetation type and tree species composition, then the stand structure for the management. Here is one case for the forest cover in low spaces based on water limit. you can say that we develop some models and some relations to link the forest coverage, the mean annual precipitation, the basin areas, the forest coverage, and so on. Use these models, these relations, we can determine the proper forest cover based on water yield requirement. The second case is the forest pattern determined based on water carrying capacity using distributed hydrological models. Use this model, we can make a lot of scenarios to analyze the response of annual runoff to the increasing forest cover, leaf area index, and the spatial distribution of the forest. If we determine the required annual runoff, then we can determine the spatial pattern of the forest. The third case is the decision procedures at standard scale. It has 5 steps. First, investigate and classify the site quality. Second, determine the main service and their priority. Third is quantify the standard structure. Fourth is to diagnose the standard structure and the ecosystem service by comparing with ideal forest. The fifth is to arrange the standard structure ecosystem service-oriented management measures. Here is one example for the site classification and ecosystem service priority. In the Liupan Mountains, we calculate the site index. We classified the site type. We arrange the priority of ecosystem service. Then we divide 5 classes, arranged the order of the service we want to manage. Then we talk about the ideal forest. This is important to guide the forest management. It's the reference to guide the forest management. First is the more general ideal forest. It composes of 3 times 0.7. One is the soil coverage higher than 0.7 to control soil erosion. Second is the canopy density around 0.7 for natural regeneration. Third is the tree height, tree DBH ratio smaller than 0.7 for against snow damage. We also have other requirements, for example, to increase water yield, to increase the wood productivity and the wood quality. This requirement can be added. The second ideal forest is the rational density of middle-aged large plantations. You can say that we develop the relations of the individual service with the tree density. Then we can determine the tree density ranges required by each service. Then we'll overlap them to determine the multifunctional one. With this tree density, 1,000 to 1,200 trees per hectare, we can get more water yield, but not lose too much other services. Then we developed the decision procedures to determine the ration tree density at virgin tree age and site conditions. First is to determine the basic tree density range corresponding to a canopy density 0.6 to 0.8 for standard stability. Second is to determine the priority orders of the forest ecosystem service at each site. Third is to determine the optimal tree density range, which can supply more than 90% of the forest ecosystem service, or the suitable density range, which can supply more than 80% of the forest ecosystem service. Then, fourth is to determine the density range. Fourth is to determine the multifunction forest management density range by overlapping the tree density ranges required by each ecosystem service. For doing the quantitative decision, the precise management, we need to develop the equations to describe the variation of canopy density, the leaf area index, the tree height, tree DPH, and the timber production variation, including single tree timber volume and standard timber volume. We also develop the relations describe the variation of undergrowth species number, the vegetation cover, the biomass, and the required leaf area index and canopy density. We also develop equations describing the carbon density variation, including vegetation carbon density and soil carbon density. Also, the relations of water yield. The water yield is calculated based on water budget in the growing season. For doing this, we developed the total ET model, which is composed of canopy interception, tree transpiration, and forest floor yield transpiration. Use these equations, we can predict the variation of water yield with tree density, tree age, and site conditions. Then we determined the tree density ranges for the multifunctional management. For example, at the elevation of 1,800 meters, it is a dry and warm site. The tree cannot grow well. Therefore, the first ecosystem service is water yield, then biodiversity protection, then carbon sequestration. The last is timber production. But at higher elevation with relative rich rainfall and relative higher temperature, the trees can grow well. Therefore, the first service is timber production, then water yield, then biodiversity, then carbon sequestration. With these ranges, we can manage the forest in a multifunctional way. Different elevation and different tree ages, we have different multifunctional tree density ranges. Here you can see the effect of the multifunctional management by comparing them with the overdense stands. For example, you can see that the tree densities need to be reduced by 60%. Thereafter, the water yield service can be increased by up to 70%. It's the most important service in the dryland regions. Then the timber production service is also significantly increased, especially for the single tree volume. Then the carbon sequestration, the undergrowth species protection, these two services is increased or decreased slightly. At the whole, that the total value, the total service of forest is greatly improved. Then we make a summary. First, that massive afforestation can reduce water yield and therefore threaten water supply in dryland regions. We need to keep certain water yield by keeping a rational forest cover, rational spatial pattern, rational stand structure, but not to lose other services too much. This means that we need a what adaptive multifunctional forest management. We developed the techniques and ideal stand structures with cases for guide the multifunctional forest management. We proved the theoretical rationality and the technical feasibility of the water adaptive multifunctional forest management. However, more systematic studies, powerful decision tools, and wide cooperations are still required, and more best management practice should be developed and widely applied. Here, I want to close my presentation with the last sentence, that we developed a new model for multifunctional forest management. This means that we need to convert the traditional forest management to a water-adaptive multifunctional management with the principles of not only site-specific and hazard-oriented, but also water-based and multifunctional. Because we not only need the quantity of forest, but also the quality of forest. And most important is the balanced service supply to the society. Thank you very much for your attention.
Yes, thank you, Yanhui, for this really extensive also insight into the so-called adaptive management for water and other ecosystem services in China, your example. Yeah, I think that's just a good basis and also good introduction also to a discussion. Please also to the audience put your questions into our Q&A so we can also then decide who will be the next speaker. But if I don't mind, I would like to start with two questions, and perhaps also to both of you, both to Mingfang, but also you, Yanhui. The first is, I've got from your presentation, from both presentations, that stand density is a very important parameter. So if more or less you have more denser stands, there might be also then more transpiration and so on, and this will more then lead also to reduction of soil water resources and also then seepage and so on. But the other point might be also the species, and I've got also from your presentation, Mingfang, that non-native species, especially if you have it in high productive plantations, might be really a problem for soil water resources. And I've got it also from your presentation, Yanhui, that you're also really thinking about how much natural development, but also then management would be needed more or less to get the balance between production and water production and so on. So could you explain a bit more species a bit more on this interaction between species density and tree species in your cases?
Maybe Mingfang, you can answer first, then I answer.
So you mean the stand density, the impact, or the species impact and their interactions?
Yeah, the question is bit for me. What is a more relevant factor? So if I think about high productive plantation with non-native species, often more or less on one hand species could be eucalyptus is known for with high transpiration and so on, but on the other hand, it's often very dense plantations. And this is often also different to native stands which are less dense, for example, especially in semi-arid regions.
Okay, maybe I try to answer your question. That in general, in forest, for the people, they would like to use the tree species, tree density, canopy density, such indicators, parameters. But in fact, when we do hydrological research, we normally use the leaf area index. This is the more scientific parameters. You can when you talk about the density, when it's 10 years, 50 years, 100 years, you cannot compare with the tree density. But when we calculate the transpiration, we calculate the interception, we use the leaf area index. Then we transfer the tree density, tree age, tree size to leaf area index. But why we use this parameter? Because if you want to use your techniques in the practice, people like you tree age, tree density. This is the reason. Also, that the transpiration is greatly affected by the tree age. In general, for eucalyptus, maybe for populus, the high speed period is about 30 years. This time they used much more water than the older trees. Maybe, for example, 6 years, 80 years, maybe the transpiration reduced half.
Yes, thank you. Would you like to add something, Mingfang?
Yes, I think the tree species that's very stand density is parameters, and species is also in fact the water, but that's really dependent on the site conditions, which environment. For example, in dry environment and or in the humid environment, so they may have different impact. And when we're talking about the water, and we usually talking about the water jet, annual water. Actually, from what water supplies, we also care about the low flows, the peak flows, and as well as the annual flows. So we're talking about the water regulations. So some species that they may reduce or increase low flows. So it's really environmental dependent, and the species is very important. So when we do tree plantings, so I think the best way we do is follow the nature-based solutions, so we try to use the native species. We try to use the native species that they adapt the environment. They have the best the hydrological functions that suit that environment. So when we do plantings, I think the nature-based solutions, we start with the natural forest, their density and their composition of species, and how their forest ages impact the water. And so we try to establish the artificial forestations, I mean the planted forest, and we try to use the nature's way.
Maybe I give some comments.
Yes.
Yeah, in general, people think that the exotic tree species use more water. Why is that? Because people introduced fast-growing trees. When the tree growing fast, they use more water. Nobody for timber production introduced the slow-growing trees. This one reason. The second is that is depending on the sickness and pest disaster and so on. So those trees might be not stable against the environment, against the pest attack and so on. In the native tree species, it is more stable. When we talk forestry, when we talk forestry, we always talk about stability, because the trees can survive 100 years or 150 years without stability, without forest benefits. So the exotic trees for fast growing is okay, but for general afforestation, for multifunction, it might be not good. We say always that select the right tree species for the right site, for right purpose.
Yeah, thank you. And perhaps one question related to this. So we always have more or less the two sides, the native species and the non-native species, so the non-native plantations and the native natural forest. Do you have also in China also the idea to combine it, to have so-called semi-natural forest, that you combine native species with a higher ecological values with commercial tree species, perhaps non-native species? I've seen it, for example, in Brazil, that they try to convert also eucalyptus stands into and to add more native species also to get into mixtures of non-native and native species. Is it also an option in China and for your purposes?
I personally not yet do such comparative studies, but we try to understand that. We do in the last several years, we do some oak transpirations. This oak is native. It looks that the native oak can save some water than the large plantations. But I think in some literatures, people say that you cannot compare the total water demand by the forest. One for the timber production forest, if you can calculate the water used by per cubic meter growth, maybe the fast growing trees is more water saving. It's depending on the place, the purpose, the site. You cannot say this is good, this is not good.
Yes, actually in South China, we plant a lot of eucalypts and for timber supply. So in South China, it's a humid area, so water is not a problem. But the problem is that when you plant eucalypts, you have low biodiversity and you may have soil acidification, you have other environmental problems, but water is not the issue. Although they consume more water, but we have humid environment there, so water is not a limiting factors. But in Loess Plateau's water, we care about the water limitations. So that's different place that have different ecological functions that have different purpose for our forestations. So it depends.
Yes, thank you for this response. And Gesche, I guess we have also some questions in the chat.
Yes, I do have a question first, and then we will read a question from the chat. I have a question related to the multifunctional management. Because I find it interesting. I mean, obviously, Superb has more the European perspective, and in Europe, it is quite often that we nowadays discuss how we can use the multiple functions of the forest, but we also have to be aware of the trade-offs. And you've also been mentioning the trade-offs. I think both of you, for instance, when we want to increase the carbon stock, that we will reduce the water yield, for instance. So I was wondering if from the how you approach this, because this is another discussion in Europe when we talk about multifunctional forest management, that we also talk about more mixed species forests, because different species provide different ecosystem services in some cases. So I was wondering what the debate in China is, because you've been mentioning the plantations, but also the more natural forests that you're promoting. So what is your take on the mixed forest, and how does that affect the water cycling?
Okay, when talking about multifunctional forestry, it's not a new topic. It's a long topic. Start from Germany, from Göttingen. When I start in Germany in 1990s, talking about the multifunctionality, close to nature. So what I talk multifunction forest today is somewhat different than what we learned in Göttingen in Germany. So the people in general, they talk about the multifunction, they talk about multifunctionality. The trees, the species, the forest can supply A, B, C, and so multiple individual services. But often between the individual services, they have competition, trade-offs. In the humid areas, maybe not so strong, but in the arid area, in semi-arid areas, the water is very strong. So we pay big attention to the competition between the ecosystem services. So when we talk multifunctionality, multifunctional forest management, we must see we must clear that what's the purpose we afforestation. We afforestation for the nature, but meantime for the people, for society. We must say what we want to get from the afforestation. In the dry areas, for example, water yield, water regulation, the water yield, water supply security is the most important. But if you increase too much forest, or when the forest is too dense, you consume too much water. You get carbon, you lose the water. So then maybe you get a negative impact for the society, for the region. So therefore, we need to balance the trade-off, the competition between the individual services. We need a quantitative decision, not in general. When I learned in Germany, that is more in general. We plant trees, when we increase forest cover, everything is solved. It's not so simple. So we need a quantitative relation. Based on these relations, we make the quantitative precise, determine how much and how big tree density and so on. In this case, you can get a more balanced supply of the different services for society.
Thank you, Yanhui. And I really like the reference to the German debate, obviously, because I'm also from Germany and I'm following the debate. So it's really interesting, like how you interpret that and that's now I also understood what you mean with quantitative, with a quantitative approach, because that hasn't been clear to me before. Mingfang, do you want to add something to that? Or yeah, please.
Oh, yes. When we're talking about trade-off, I haven't mentioned it in my slides actually. We're talking about the trade-off between, for example, like the carbon and the water yield. And so actually it's really dependent on what kind of hydrologic variables you are focused on. So there are various hydrological variables, and as I just mentioned, their annual water yield, and there are also low flows, peak flows, and the forest can, in our opinion, we want forest to increase low flows, because in dry season we need we want more water supply, and we want the forest can reduce peak flows. That's what we want. It can maximize, it can reduce the flood risk, right? So when we're talking about trade-offs, and I have provided examples of the published papers, they all only consider annual water yield. So in our future and my ongoing research, and we're trying to calculate an overall index that express the hydrological functions. So it's really a trade-off between the carbon and a very integrated hydrological function, not just any runoff.
Thank you, Mingfang, also for kind of specifying. I would like to read a question that comes from the audience, from Ida Lobkowitz. And she is asking what different time frames you use to assess the impact of afforestation on the water cycle.
Time step?
The time frames that you use.
Time frame?
The time frames, yes.
The study I present in my slides, or?
I think this question is to both of you. She didn't specify.
Okay. So the time frame, it's really depends on the records of your hydrological data. Yeah. So for the watershed studies, the time frame and the longest paired watershed study that can be over 100 years. We can see a long record and how forests change the stream flow and the stream flow recover, and we can see the long process. And also, if you have just a short record, you may just focus on the hourly, daily data to see their seasonal or the daily changes of the interactions between the forest and water. So it really depends on your data records to define your time frame, I think.
Yeah, in the studies we did research in different time scales, from maybe minutes, an hour, an individual rainfall event, 1 day, and 1 year, and many years, depending on your research purpose. Yeah, if you want to get understand the hydrologic process, you need to do the very fine studies. If you want to convince the people, the politicians, maybe talk about the long-term outreach impact.
Thank you for also providing an overview of the different, because it really obviously depends on the research approach and the research question. We have another question to you, both of you, from the audience, which is, how do different forest types like conifer forest versus broadleaf forest impact the water infiltration and the runoff rates?
I learned from Germany. Yeah, the colleague in Germany, in IUFRO, Miller. Yeah, Dr. Miller. Yeah, that in Europe, in Germany, yeah, the conifers consumed much more water than broadleaves, because you have a long winter, many snows. But in China, we don't have such studies to compare that. But maybe broadleaves consumes much more water. It depends on the growth, the growth faster or slow. But we in northwest China, we don't have so much snow. It's different. We had that time we have my discussion with Dr. Miller. Yeah, it depending on the broadleaves and the needle trees, but also depend on the tree growth, faster or fast growing or slow growing. The density is a lot of parameters influence the forest impact, not only one factor. Sometimes it's difficult to answer, but in general, that fast growing trees use more water.
Yeah, perhaps that, because you mentioned my colleague Jürgen Müller. Yes, especially for Scots pine. So, and the problem with Scots pine is that they're neither growing fast, but on the other hand, nor saving water resources. So, and this is of course, as you already mentioned, as an evergreen species, it more or less has also water losses during interception losses during winter and so on, and also with the undergrowth. You also mentioned, I guess, also the very important role of undergrowth, like ground vegetation and so on. And this is also much larger, and we have tall grasses, yes, for example, in Scots pine forest. It's a bit different for our other main tree species, which is Norway spruce. But of course, I think we know, and especially in our region, that Scots pine is really not very valuable for the groundwater table in our regions here. And this is also a point for climate change. Climate change is coming, and we had 3 drought years in a row from 2018 to 2020, and we have really a reduction of the groundwater table for 1 meter, 2 meters, and in large regions of northeastern Germany. And Scots pine is one element, problematic element of it. Okay, yeah. I have also one question, and I think it's interesting. I think Mingfang, you mentioned also, and also Yanhui, I think the really impressive success of afforestation or reforestation in China. So I guess you can say that China is a world champion of afforestation or reforestation in the late 1990s and the beginning of the 2000s with, impressive new forested area. And in February this year, I think that the Science published, I think, a very interesting paper from Catherine Parr with the title "Conflation of Reforestation with Restoration is Widespread," and they were very critical, especially of reforestation in the case of Africa. But I think you can also relate it also perhaps to semi-arid regions in China. Then they said, and one argument was also the higher water consumption of forests compared to grasslands. So what is of course often the case. So what do you think is if you would be able to turn the time back? Do you think some of the forestation activities in the late 1990s and 2000 were perhaps not such a success from the perspective of the groundwater table in some parts of China? So would you recommend more or less then perhaps in some cases really to stop or to reject afforestation or reforestation?
Okay, I can try to answer that. In the past several decades, China have a big effort to increase the forest. I think that when I was a student 40 years ago, 50 years ago, so what we learned that the forest can solve all the environment problems. More forest, more water. We learned from the university course that. Yeah, but I think that at the beginning in the 1970s, why we do the Three North afforestation project. At that time, we afforestation with the main purpose of reduce the soil erosion, sandstorm. This is the most important purpose. And at that time, people don't know that forest consumes much more water. The water limitation is a factor. The people think that if we forest more forest, we will have more low flow, more water. This theory was wrong. Now we realize that the forest use more water than grass and shrubs. Then we talking about the right place, the right species, the right forest cover. Not too much. The water determined afforestation. Now the policy was changed. All depending on the available water. The water used for forest, not only for forest, but also for agriculture, for industry, for people's life. All activities should be according to the water, especially in the dry areas.
Yeah. Thank you. Yeah. I think this is interesting. Oh, Mingfang, you would like to add something?
Oh yeah, yes. We actually when we now do plantations, we need to access the water carrying capacity of the areas. Yeah. So first, and then we do planting. So.
Yeah, I think it's interesting. I think this is it's always the case. There are lessons to learn. So that with the trade-offs, and I think there are so many cases throughout the world that you start with something and you don't have and then you detect there are some trade-offs you haven't expect from it.
We also learned a lot from Germany, especially in the forest management, thinning and the close nature forestry. Now we want to also use these techniques to save more water. For example, we have in the past we produce a lot of overdense standards. Because the people use the forest cover is one parameter, then the timber volume is another parameter to assess to evaluate the success or not. But now we learn that we should evaluate with more balance service, more service. So we try to give more attention to the right the forest management to get maybe the overdense forest. We need the thinning, the sparse forest, thinning the forest to produce more water.
Mhm.
Yes,
Yeah,
I think yeah. There's
Sorry.
one more thing, yes, sir. There's one more thing we need to consider. That's actually when the trees transpire water and it becomes the vapors that in the atmosphere, and they become the precipitations, and the precipitations will fall in somewhere else. I mean, the water, where do the water goes? Yeah, they will benefit some region else, not locally. So when you look at the problems and the bigger spatial scales, this is not a problem. I mean, the water loss is for the local scale, for the downstream. But when you look at the larger scales, the forestation, when you, especially a large area of forestation, they play a very important role in regulate the precipitation, regulate the climate. So they will have other benefits, the waters. So it's really very complex. So that's why my title is Complex Forest and Water Nexus. Yeah.
Yeah, of course. I think this is also something you always have to mind. You know, the amount of water could be transpired.
Yeah.
So it's cooling the climate, also positive effect, but it's lost for the runoff. So the other one, which is going to the runoff, cannot be
not
transpired.
be here, but somewhere else. Yeah.
Yeah.
So there's also a trade-off, upstream with downstream, upwind and downwind.
Yeah.
Yeah. So, but Geshe, I think we have 2 questions also in the chat.
Yeah, we have. I would like to start with the question from Riccardo Nicolacci, which is he's asking if the connectivity between forest fragments is an important factor for the forest to provide ecosystem or like water services. So what role does the connectivity between forest fragments play?
Forest fragmentations, yeah.
For the provision of water services.
A good question.
Okay.
Huh?
Yeah, actually, it's a good question to start is how to study the connectivities between the forest landscapes, that the forest fragmentations that will actually affect the hydrologic process. Because like if you have separated the hydrological process, like the runoff, surface runoff, right? Especially, I think we have some study the forest roads. I mean, when we do logging, and they build they may build roads, and the roads will divided the forest and lead to forest fragmentations, right? And so these fragmentations will increase surface runoff. I think these studies that's where related to the connectivities, because it changes the connectivities of the forest landscapes when we do forest loggings, the forest roads. There's a lot of study this topic.
Well, another factor that the trees at the edge, in general, they grow faster than the trees in the forest. If you get fragmented forest, maybe the same area of forest, maybe they use much more water than the bigger forest. But no people do such research, I guess.
Yeah, it's a very good question.
So yeah, something to be followed up upon.
Yeah.
Yeah, a doctor thesis title.
Okay. Sounds good. There's one more question in the chat, which is a little general, so I will try to specify it a little bit more. the question is, can sustainable forestry practices be implemented to minimize disruptions to the hydrological cycle? And I would like to specify it like what type of management practice can be implemented to minimize the disruptions to the hydrological cycle. So to be a little more precise. What forest management practices do you suggest to minimize the disruptions?
That we have approved, we suggested a long time ago that to integrate, we also with the German colleagues, to integrate the water aspect into forest management aspect, because in the traditional forest is timber production oriented. So the techniques, the guidelines, all think about the timber production. Water is not a limited a factor to be considered. Now we suggest for a long time that consider the water requirement into the forest management, into the forest planning. Now in China, this is changing, but it needs a long time. You know, you don't have the standard, the guideline, how much impact.
Okay, so what you mean is it should be implemented into the management planning as one relevant factor, but it is not yet considered everywhere.
Yes. In some pilot project, we might try to according to the water impact, hydrological impact to manage the forest just in the start phase.
Okay, so it's also something that obviously needs to be monitored and accompanied with science so that we can actually have proper results in a couple of years from now.
Yeah.
Andreas, you still have a question? Yes, please go ahead.
Yes. I'm also a bit curious about this spatial effects and the role of scale. So I think in Germany, but also in parts of Europe, I think we have a vital discussion about different concepts of integrating ecosystem services like water, but biodiversity and nature conservation. So on one side, or more, let's have more segregation. So to have special sites who are, mainly important for, nature conservation, biodiversity, so reserves. But also, what do you think about the idea to have really, segregation and forest mainly for, water purposes? So to produce, would it be also interesting concept for China to say, okay, we have, of course, perhaps other ecosystem services, but we have a major focus on water production in these areas?
Yeah, in China, the forestry development, in the past that we mainly for timber, for timber production. Then later we have this concept that for soil protection, maybe for water resource protection, we call this classified forest. It's not, for my opinion, it's not good that you waste the land, waste the productivity. So we as I said at the beginning, every forest can supply multiple services at the same time. If you just use one, then you lose others. You lose the productivity. You lose the value of the land. But anyway, that in different regions, the dominant service is different. In some water heat areas, maybe water related service is the most important. We call it a dominant service. Then in some fertile site, like in South China, timber production is more important. Okay, you use the dominant service as timber production, but other service not forget to balance. Maybe, for example, you can reduce some timber production service, but it can increase the biodiversity, increase the water-related services. Then you need to add all the value of all the services. You lost maybe $10 for this service when you get maybe $100 in other services. It depends on the total value. Also, this value is related with the social demand. What's the people demand from the service, from the forest? It's also important. So we talk about the multifunctional management, balance the supply of multiple service for the people.
Yes,
yeah, we learned from them.
Yanhui, but I got also that, of course, okay, multifunctional, but priorities should be set in some cases.
Yeah, you must
Okay.
firstly classify the site types. Yeah, for such type in these regions, the number one service is what, the second, the third is what. Then you can determine the right techniques for manage the forest, the right stand structure.
Okay, I understand. And Gesche, I guess, and you also promoted, I think, one chat, I think, from Adam Bay, and he is more or less the coordinator of the task force on forest and water interaction. I think that's a very special, bundle of papers, special issue also, which also more or less give a more broader also insight of this water and the forest and water interactions. Yes. So, Gesche, do we have still questions in the chat?
No, we don't have any questions in the chat. And I would like to, thank both of you for your presentations. There were lots of formulas and numbers in the presentations. And I was a bit overwhelmed listening, but when we had the discussion, I understood much more. And this is also why it is so important to have this exchange and to be able to ask questions. And it was then quite practical also in the end. So thank you for showing both of those perspectives, because I know that the formulas, for instance, are very important for some of the scientists that are joining, and then others are more interested in the practical implications. So that was very well covered today. I would like to ask my colleagues now to share the final slide of this webinar. Yes, we have a next session on the 8th of May. We will keep you posted. We're still discussing the topics, but quite soon we will make a decision. And then for those who are in the webinar still, please follow us on our social media channels or go to our website or the LinkedIn, and then we will inform you about the upcoming webinar. But we can assure you it will be exciting. Andreas, do you have anything to add?
No, thank you also and I really would also like to thank you. It was really inspiring talk to both of you. It was really nice also to discuss about it. As you already mentioned, I think it's very important to more or less to have different perspectives and to discuss different aspects and questions of it. So I think it was really a successful monthly forest restoration talk session, this one. So, and I really would like to thank you Mingfang and Yanhui, for your contributions.
Yes.
Thank you too.
Thank you, Andreas.
Have a nice rest of the day.
Thank you.
Bye bye.
Bye bye.
See you.
See you.